heavy burden, and then really to lose the attention of the domain.
Any question? If not, thank you very much, Martin, once again. And the next presenter is Matthew Harrison from the British Geological Survey. He's a facilitator of the Natural Risk Zone data team, and he will present the final work of this team.
You said it wasn't final.
Release candidate.
I thought I got away with it then. Okay. So, I'd like to present the work that we undertook as part of the Natural Risk Zones data specification group. In common with many of the other groups, we had a variety of issues about scope, about complexity, but one of the issues that we had, which perhaps wasn't as dominant in some of the other groups, was about the whole, well, the conceptual space of what natural risk zones actually are. The domain is very, very broad. We came up with a list of 82 natural hazards that could potentially affect Europe. We knew that wasn't exclusive, or it wasn't the end of the list, so we kind of stopped adding them at that point. And also, one of the things that became quite apparent looking at the input information and also as part of the consultation was that there aren't an awful lot of risk data sets that are actually produced across Europe. There are hazard data sets, there are quite a lot of susceptibility data sets, and from a geological survey perspective, I'm very familiar with susceptibility data sets, but it's not very common to go all the way to risk. So I'm presenting on the behalf of the whole group. It was well represented across Europe, particularly well represented for Spain and Catalonia. So this was the definition that came out of the original legislation that did a fairly good job of defining what natural risk zones were and gave some examples. But what we very quickly realized was that the domain was broader than the examples that were listed, and that we needed to have something that encompassed all of those. One thing that was very clear is that our group was made of 9 people or so, and we only had very limited experience across the breadth of what natural hazards or natural risk zones were. So in terms of how we went about the work, there were reference documents that were provided at the beginning, and also some pointers to some existing projects. There was the Floods Directive, and the Floods Directive has been both something that's been very positive, but it's also been quite difficult to deal with, because there really have been very few directives. Well, in fact, there have been no other directives that kind of crossed into the domain of natural hazards. So it was very hard to balance, cosmic hazards against something that was a fully fledged directive that had people that were working on it, and one of the group was working with us very directly. So we had to balance all of these different things. And also that we had one feature class that came from hydrography. Hydrography had very helpfully identified that an object called inundated land was related to natural risk zones, but we, as a group, we kind of decided that wasn't really the way we wanted to model the problem. As everybody's talked about, there was the public consultation on version 2. We weren't winners. We were runners-up, perhaps, in that competition, thanks mainly to some people in the audience. And it was very, very helpful, because what it enabled us to do was actually look at where the problems were with our models. And And thankfully, a number of the problems with our version 2 model were actually around the communication of what we were trying to do. So we were able to tighten that up very much for version 3 and look at some of the issues, some of the other issues that stood out, multiplicity, how coverages fit in, things like that. This is an interoperable slide that was taken from some of the previous speakers, and it's about finding this balance, between something that's simple and easy to use, and something that's too complicated or is complicated and actually provides a level of interoperability that isn't necessarily required. It would maybe be desirable but not required. So, as part of the scoping, we produced some use cases for floods, and that formed the basis for discussion with the Floods Directive people, but also for landslides, for forest fire, and earthquakes. Now, the forest fire is a very interesting case because in the forest fire domain, they don't really use the terms hazard and risk and things like that. They use the term danger. And danger is something that kind of embodies a number of these different concepts. So in version 3, what we've done is we've taken that use case, and we've also translated it or demonstrated how those terms, their terminology, the terminology of that domain, can translate into the terminology we've used in our model. Another issue that is ongoing about actually categorizing these hazards. One of the things that we, as a bunch of scientists, really felt was very important was that you had to know what hazard it was that you were dealing with, and if you had a risk zone, you had to know what it was affected by. We didn't see that kind of this vague concept of something being hazardous and something being risky was particularly useful, especially in interoperability terms. We expected people would want to know what they were to do about it. And as a result of the Floods Directive and the floods use case and the work that was going on in parallel in the Floods Directive group, we had a meeting with them, and there was a further meeting with them more recently, just to make sure that everybody understood what we were trying to do, we understood what they were trying to do, and we've, at the end, we've provided an example of how our model could be used in the floods domain. So this is a diagram that we've included in the guidance document that tries to explain what the various concepts are. Now, I'll go back to that in a minute, but what we're really trying to do is we're trying to encompass the risk equation, where risk is a product of hazard times exposure times vulnerability. So in pictorial terms there, what we've tried to do is actually identify those elements in that diagram. And one of the things that is interesting in that diagram is this concept of things that are being exposed but also have a vulnerability. So if a vulnerability is actually known about, then that vulnerability can be included and used to either define a risk zone or to define things that are outside a risk zone. So more formally, we also came up with a diagram like this that helped us, because as groups of as members within the thematic working group, there were times when we understood that we were talking different languages, and I had a few headaches, and so we needed to formalize what these things were, and so we came up with a diagram like this that clarified what these relationships between concepts actually were. So when we came to, it says final there, that was hopeful. What really we were trying to do was to design a generic model that was valid for all the hazards that we could think of and those that we didn't know about yet. that would apply to both vector and coverage data. For some of the communities, it was very important. The forest fire community, for example, they work quite a lot in coverage data formats, so we needed it to be valid for those. And also to make sure that the floods directive people felt that we weren't overstepping into their territory. So that's our model, and that's the entirety of our model now. It's actually quite simple. We've got the three main concepts, I suppose the central concept being hazard, because what we felt was that at a minimum, what a data provider would have would be some hazard information. If they had information, if they then went on to produce a risk zone, then they would have to actually have exposed elements and a vulnerability for those things. And so it's the relationship between each of those individual feature types that is important. And those feature types are broken down with some simple, fairly simple, high-level attributes that help people actually use them. And I think in this, yes. So one of the other things that we understood was that there was a kind of a special type of hazard areas, and that's kind of recordings of observed events. And so that's the fourth of those boxes there. Again, as I say, what we were trying to do was we were trying to simplify all the time, make it broadly applicable, but also as simple as possible to use. So we were able, vulnerability has floated around, and those of you who might be familiar with our version 2 model, it didn't look anything like this. We managed to understand that vulnerability really is a property of something that is exposed, and so we managed to simplify in that way. Code lists have been an issue for us, as with everybody else, and in the end of the day, what we provided was a simple, high-level code list that broke down into a very small number of natural hazard types, and those hazard types are applicable for both the hazard objects and the hazard feature types, and also the risk feature types. But it draws upon some of the international standards. Well, there are no formal international standards, but it draws upon some of the widely used international things, like from Munich Re, UNISDR, some of the big organizations in the natural hazard environment, or the natural hazard domain. But one of the things that we have also done is we've allowed a free text box so that people can use it to refine the classification. So at the very, very simplest level, there is interoperability between these different types of hazards, so that if in one member state they're monitoring floods, and in another, floods are actually classified in the same way. But at the same time, you can go into further detail, and some member states perhaps might have a subclass of floods, like groundwater flooding, for example. And potentially in the future, as part of the maintenance procedure, we can actually look through what those what those free text fields are actually saying. And as Google does, for example, it doesn't set up a formal classification for things. What it does is it actually looks at what's being used and tries to draw information out of it. So one of the things I very much hope is that we can kind of crowdsource what is a natural hazard classification scheme, because believe me, we had plenty of discussion about it within the group, and there were plenty of comments from external. So in the spirit of being fairly simple, we actually haven't required very much as part of the implementing rules. I think there are a very few of those. The ones that are highlighted are the ones that we've specified. The other ones are actually ones that come from the generic conceptual model, so they're across Inspire. And in terms of recommendations, again, what we've done is we've kind of discussed things that have been in the guidance document to provide background and something that's useful for people, and we haven't really provided anything that is that goes into the implementing roles. One thing that has been very interesting is it's been about linkages, and as with so many of the other thematic working groups, when we were at version 2 and even at version 1, we had a star-shaped diagram where natural risk zones, because that's what we were dealing with, sat in the middle and linked to many other of the thematic groups. But for some very obvious reasons, that there is an awful lot of complexity within our own models, let alone trying to join up with other people's models. In the end, we've only got 2 formal links to administrative boundaries and to environmental monitoring facilities, where we use some of their concepts and link them back to natural risk zones. As I say, one of the things that we did was we provided in version 3 a floods example. So we've taken the core of the model, and we've specialised it to meet the requirements within the floods directive. So those main concepts are actually there within that extended model, but actually it also demonstrates the relationships with other concepts and other terms that are used within the floods directive, and clarifies how they relate to each of our core elements. It is just an example. It is just an example of how you could specialise our model to be applicable in the floods domain. Just as a summing up, we've, like others, we've got some member state concerns to deal with. I think there were 11 on that list that Robert showed earlier. We will address those, and they'll be published as the implementing rules. One of the key things that is important now is to promote the work that we've done widely. There is still quite a lack of understanding beyond the Geological Survey community. I think especially I presented this work at a more academic conference 6 weeks or so ago, and they were quite surprised, shall we say. They weren't. There was a deal of animosity about what Inspire was going to mean for them, because many of them, although they have a more academic view, they are producing public sector information, and they felt that they didn't understand about Inspire and about, in particular, in this instance, what we were trying to do and how it would affect them. So there is a lot of work now in actually bringing them on board, I think. And one of the things that they were particularly interested in, after having a bit of a go at me, was about what the maintenance process was and how they could engage with that. So if they had felt, and if anybody in the room feels that they haven't been engaged enough and it doesn't take into account their own domain, then the maintenance process, as and when it is actually finally approved, I think will be the way to join up and make it usable. Because one of the things I've said to our group all along is, the thing that I'm most interested in is making it useful and usable to people. So that's it. Thank you.
Thank you very much, Matthew. Are there any questions to the natural risk zones to Matthew? Everything was clear? Okay, so thank you very much once again. And the last presenter is Arnold Ardondussen from the Norwegian